All right. Thank you, Bo, Martin, and Fred, for that great session. So I'm going to open up the floor first to any audience questions. I've obviously got some prepared here, but I want to make sure we get to everyone's questions. So just wave at me if you have one, and I'll invite you to turn your microphone on. So go ahead, please.
Andrew Scott, GMG. Fred, great presentation, and it's good to see the progress. Of course, all of us would love to see it happening faster. And you mentioned 7 or 8 years work. There's also all the pre-work before that. My key question is, how can we, because we're getting into the sort of the final stages of MinEx, and so we're more or less running out of time in this phase of the project. In your opinion, how can we accelerate to get some of these faster and getting to that point where we can be using these tools out in the field?
I think key is just to get enough field testing of them to prove them up and to get people familiar with the different data types. I think petrophysics has been underutilized in mineral downhole. Petrophysics has been underutilized in mineral exploration, and yeah, it's really building it into those workflows, demonstrating the data and what both of the technologies can do. And so yeah, it's really getting them out there and tested and
Great. Okay. So my first question is for Bo. I thought it was going to be for you and Brandon, but you're going to take these questions solo.
Okay.
So I thought it was super impressive that you keep those holes open for so many days with water coming up, water on top, water everywhere. You mentioned the mud and the different chemistries and mixes that you used. Were there any technologies that also helped you at the surface?
So this was not approached necessarily with a standardized core drilling suite of tools, in a sense, with your typical rock drilling core barrel assemblies. There was a section that was drilled with HQ core barrel assemblies, but this, part of what contributed to the recovery aspect was a specialized suite of soft sediment sampling tools that's kind of very, very customized, and Matrix Offshore Services provides those. But that's speaking to core recovery. Drilling fluid does help with core recovery. But as far as to keep the holes open, it all really came down to, my opinion, the fluid used, but also the driller's approach, right? If they, we wanted a fluid that was going to have good hole cleaning and lifting capabilities. It needed to have a low-end rheological profile. We need to be able to, we want it to be thin so that it'll flow, but we want it to be thick to be able to carry the cuttings. And I can't speak too much to the ingredients of what's in it because it has a proprietary polysaccharide ingredient in it, but the X-Form D, it made all the difference in the world for being able to keep those holes open, in my opinion. We had a guy that's been with the British Geological Survey for 47 years, numerous people that have been in this type of drilling environment, and it impressed them greatly, and that's one of the contributing factors that I think ultimately helped with that. So
yeah, I'd like to bring you into the conversation, Martin, because the technology that you're developing there seems to have fewer people at the drill site, whereas Bo's example seems to be that the more heads in the game coming up with solutions is better. So I invite you guys to have a bit of a discussion about that, of more hands versus less, more minds versus fewer contributors?
Well, I guess, if you look at the technology that Heisman developed, it's 2 drillers. So you're actually just removing the drillers, having fewer drillers and drillers' assistants. You'll still have the clever minds next to the drill rig to understand, how do we mix the muds? And I think they'll still be there. And I think the people looking at the core will still be there, but I think limiting the amount of people actually close to dangerous, rotating parts. That's the idea. I don't think it's one or the other. I think it's just where we remove the people.
Going to scare everybody. Technology is taking over. Automation is taking over. If helpers can't mix mud properly, they're going to get replaced by a machine that'll do it and do it perfectly and not get hurt and not, cause financial issues as far as, limiting productivity and whatnot. That being said, does mud testing equipment go that same route? I mean, everybody's going to lose their jobs in a sense, type of thing, right? I mean, that's ultimately what happens. You get replaced by a machine. Do I like it? No, but maybe that day comes, right? I mean, let's not beat around the bush, right? I mean, it's what everybody's working towards. So the human element is a very real thing to try to battle. But in the time being, everybody has to pull together and try to work to try to overcome those things. And so more heads looking at it, trying to ensure that things can try to stay as consistent and as productive as possible is where we're at, right? So.
Okay, Fred, you used the term data rich a couple of times of all that data that's coming out of the hole. How do we make the decisions as to what data we collect and then feed into AI models, feed into interpretations? Do you think people will start to get overwhelmed with how much data is coming out of a single hole? Are we collecting too much?
I don't think you can collect too much data as long as it's the right data and it's giving you more information about the hole. But yeah, data overwhelm, it's absolutely an issue. Even with that, some of that swept frequency data, it's 150 channels collected every second. It's a massive amount of data because and then looking at in phase and out of phase and all that. So you definitely have to build the automated processes on that to distill that data into something that you can use. And for the example with the libs as well, it's collecting that very large amounts of data that are completely built for the machine learning models, and some of the work that they're doing is the machine learning and geophysics-based calibration approaches as well. So, yeah.
Based on that response, I wanted to invite Ua to maybe contribute to this conversation. Hearing these three presentations and what you're learning from other industries and other applications, have you had any ideas while you've been listening of how we can use AI, machine learning, different tools to help some of these processes?
It's very exciting to see the level of automation, use of technology, and to your point, the day is coming that a lot of the things that we do and processes that we do will just become more automated. And you saw some of the agents that I showed, and in my mind, I think we should think about it as an evolution of our work and how can the human be unleashed to do more high-value work. So most of the use cases I saw, imagine all of that sort of in the connected mining, a digital mine type value chain. And that's what a lot of operators and services companies are trying to do. Sort of what does that look like from, sort of exploration, all the way to down the value chain to smeltering and processing and all of that. And imagine sort of a connected thread of data. I'm thinking about what MindSense, because they spoke last year, and the sensors, and you have sensors from the shovels, and all that feeds into the data. So that's sort of, at least for me, that's the mental model. All the use cases have a role across the value chain, and there's this connective tissue of data across it.
Awesome, thank you. Were you waving? Did you have a question there, Dave?
I thought it'd be an excellent concept to have a Fred AI agent sitting in an edge computing device at the rig, inspecting, yes, to simulate a Fred as an AI agent that's looking at the data that's coming off the swept frequency tool as it's doing the measurement. Because that does open up other workflows as well, because if you're looking at the data, doing more than looking at the data as it's being collected, you may change the speed of the logging tool to improve the quality of the data over specific intervals to add even more value to it, I think. So it's the sort of thing that an experienced operator looking at the dials would do, but again, the people thing, you'd need another person out in the middle of nowhere doing that. Why not have an AI agent that is trained looking at the data as it's being collected in real time, so you can make that decision then and there.
You better copyright yourself, Fred. There's going to be AI Fred on drills. Are there any other audience questions that have come up while we've been talking? Go ahead.
Yeah,
John?
John Thompson, Petroscience and others is my affiliation. Question for Martin, actually, a practical question. You said the Huisman rig is expensive, and obviously it's a pretty fancy looking big piece of kit, so that makes sense. But you said it's 25% faster. So is that close to payback, or how fast does it have to get to be cheaper?
Yeah, so that calculation I haven't done, but what I can say is where it's really going to perform is if you have a deposit drill out. So I see it as a near asset type tool. We've got a lot of meters to drill and not far to move between holes. So yeah, I think there's a definite business case in that. And we've been having discussions with Huisman to say, you have to change your business model here. Do a rent to own, or there's some other way that you should be doing this to get the rig into the market. Because I think it's, I think there is definitely value in it. But yeah, it needs to be. It's not going to be in the Andes in the mountains. It has to be near asset or on a deposit drill out, because it can really. They were doing some studies, sometimes studies where you would take 10 years to drill out a deposit, and they could halve that time with their calculations, and that greatly improves the NPV of a project. So it kind of blows it out the water.
And a follow on quickly is, can you put downhole tools down it as well?
Yeah.
Quickly and efficiently.
Yeah.
Okay.
Yeah.
Go ahead.
Hi. You're all going to hate me. It's not really a question, but just kind of like a comment, because I thought, oh, this is such an excellent opportunity. But to Martin's point about the study with the doctor and how he was able to discover, oh, well, it's the germs from not washing our hands. To go a little bit further into that story, he was actually not accepted by his peers. In fact, he was criticized. He was ridiculed. Guys, he went into a nervous breakdown trying to convince his colleagues that these germs were killing mothers. He went into a nervous breakdown, and then you know what happened? He got tossed into an asylum by his colleagues. He was lured there and said, oh, you got to go in. This guy's crazy. And then he was beaten to death. Okay? So the really fascinating part about this is that, we have to ask questions, 100%. It's complicated enough trying to ask the right questions, but God forbid if you are somebody of color, of a certain race, like the discrimination that can really limit other people's ideas when they bring up these questions is fascinating. And so I think as an organization, and Anglo does this really well, is like recognizing, inherent systemic discrimination, any bias, vibes, like anything that is kind of going in the back of your mind, being like, I don't want to listen to this person's nuts, especially with technology these days where, it's confusing, right? And so I just wanted to add to that. Crazy story, but yeah, thanks, Martin. That was very inspiring that you brought that up.
Yeah, thanks for that. It was a very different take from my technical side, but yeah, thanks.
To continue on that theme of the technology scouting that Anglo did, how did you decide who to invite into the room? You said that you had participants from different sectors. How did you decide who came into the room, given how specialized drilling is and how much we rely on it?
Yeah, unfortunately, I wasn't part of the team that selected those, but we had a technology development division that was working on that, and they had 2 or 3 other open forums prior to that. So I think they kind of learned to invite in, and it was more about the individual than it was the industry that they came from. What we needed were people that would go, I'm going to use the whole of my brain to unpack this problem and not stick to their lane. So it wasn't come and pitch your project or your solution from your industry. It was literally like going, what can we get on paper here? What can we use? What can we, just really spitballing things. Some of the ideas were really strange. That I think there was one thing was called the octopus drill, which was a drill with 8 or 9 different drill bits on strings, almost like a coil tube with 8 or 9 and kind of drilling. So there was some some really strange ideas. So it's about the individual. So they'd selected some of the same individuals from previous ones rather than the industries.
And did you end up inviting anyone who sent you a LinkedIn message?
No. No, but I did speak to a lot of the people that sent me LinkedIn messages. I did have conversations with, because some of the ideas were quite interesting. And like I said, most of them were snake oil.
Okay, yeah, go ahead.
Yeah, I guess like sort of the sales pitch I'm hearing from you three is the oil and gasification of drilling. We have bigger rigs, 24/7 mud professionals, and now downhole tools that the oil and gas industry has been using for 20, 30 years. What else can we steal from them to make the mining industry more efficient? And is the mining industry ready for that cost profile that comes with that?
Yeah, I think it's coming. I think that as time goes on, they'll find ways to incorporate it. But has anybody done the math and do you guys even really know the issues that are happening out there and the costs that's behind that? I don't think people have really put a dollar value to the inefficiencies, right? So it's a very real thing to compare. As much as technology and automation is a little bit of a threat, there's also opportunity. They've got, they're working on automated drill rigs. They've got autonomous haul trucks. I mean, it's for a lot of us that are workers in the field or whatever, it's a threat. But as far as the return on investment, there's a lot to unpack there, as far as what those costs are versus the investment of it, right? I'd kick it over to a colleague. They have something else to add to it.
Yeah, I think my opinion on this is, if you drill a oil and gas well, it's millions of dollars for that one well. So you're trying to get as much information from that one well as possible, and that's why a lot of these tools, downhole tools, were developed. I think we in the mining industry can probably use those tools in a slightly different way, use them to change our workflows. If these tools exist, they're commercial. You would probably, instead of diamond core every single hole, you might do RC or percussion and send these tools down. So you would potentially drill more. You would 3D map instead of surface mapping. Now with the cover, you can't do that. So you'll potentially do 3D mapping with drilling, using it as a mapping tool. So I think the oil and gas technologies might just give us a different workflow to get to the same result. That's the way I see it. I don't think we're going to adopt everything they do, and it's too expensive. But I think some of the tools we'll selectively use.
Yeah, I 100% agree on that. And one of the things I think is as well, it's the standardized, very standardized workflows that are in oil and gas. If we can take some of those kind of processes and do the full logging suite, petrophysical logging on each well, collect that data and keep that data that flows through the entire value chain, really, something we can change.
Perfect. And we're right on time. So if everyone can join me in thanking all the speakers from panel 1.